In this video, you'll learn how to create a complete RESTful API using plain, object-oriented PHP and MySQL. All the code developed in this video is free to download and use, and a link is in the description. To make API requests, you'll need an API client, for example curl, Postman or HTTPie. In this video, I'll be using HTTPie on the command line. We'll start with the API endpoints. First, we'll create a new file called index.php. In here, we'll start with the PHP opening tag, and for now, let's just print out the value of the request URI element from the server superglobal. Let's see what response we get from that page. On the command line, using HTTPie, we make a GET request to that page, and we see the response status code, which is 200, the response headers, and the response body. In the response body, we see the output of the vardump call, and this is printing out the path part of the URL, /index.php. If we make that request again, but remove the index.php part, as index.php is the default, the request still works, and the value we get printed out is just the slash. So this server variable contains the part of the URL after the host name. As the API is going to be RESTful, however, we want a specific endpoint URL format. A RESTful API consists of two URLs, one for a collection of resources and one for an individual one that contains the resource ID. The result of calling the endpoint depends on the combination of the URL and the request method used. So in order to have RESTful URLs, we need to do some URL rewriting. As I'm using Apache, let's add a new file called htaccess where we can specify server configuration settings. In here, we'll turn the rewrite engine on, then add a rewrite rule with a pattern of a dot that matches any URL, and we'll substitute this with the index.php script. Basically, this says that any URL will now call the index.php script no matter what it is. These rules are only valid for Apache and compatible web servers, and I'm deliberately keeping this very simple for the purposes of this video. But if you need the rewrite rules for another web server, let me know in the comments. Let's give that a try. Now if I make a request to any URL, the index.php script is executed and we get the path part of the URL printed out. As an aside, with HTTPie, the default request method is GET, so if we're making a GET request, we don't need to specify the method. Also, the HTTP protocol is the default, so we don't need to specify that either. Now we have access to this part of the URL from our code, we can parse it to get the segments we need. So instead of printing this out, we'll use the explode function to split it up using the / character. We'll assign this to a variable and print that out. If we call the /products endpoint, then we get an array with two elements. The element with an index of 1 containing the string products. If we add an ID to that endpoint, then this is placed in an additional array element. We're just creating an API for products, so if the URL is something else, we'll respond with a 404 status code, which you'll no doubt be familiar with. So, instead of printing this out, if the first segment isn't products, we'll call the HTTP response code function, setting the status code to 404, and we'll exit the script. As for the ID, this will be the second segment, or if it's not specified, we'll default it to null. For now, let's just print that out to see what it contains. If we make a request to an endpoint that isn't /products, we get the 404 not found response. If we make a request to the collection endpoint, we get a response with a status code of 200, which is the default success response code, and the ID is null. If we add the ID to the URL, we get this printed out. Note that for the purposes of this video, I'm keeping the routing simple, with a simple rewrite rule and parsing the URL manually like this. In a more complex project, you'd probably use a third-party router component like FastRoute to provide the routing. Next, let's add a controller class to control the response to this. First, let's add a new folder to store the class files called source. Then a new file in here called productcontroller.php. In here, we'll add the PHP opening tag and the class definition. Next, let's add a public method to this called processRequest. The response depends on the request method and if there's a resource ID or not. So let's add a string argument for the method and a string argument for the ID. To keep it simple, we'll just echo out the response from this method. So we'll declare the return type as void. As we just saw when we made a request, the ID can be null. So we'll make this type declaration nullable. Inside this method, for now, let's just print out the values of these two arguments. Back in the index script, as we're using type declarations, let's enable strict types at the top of the script. Then, in order to use the class we just added, we need to require the file that it's in. Instead of explicitly doing this, as we'll be adding more class files later on, let's add an autoloader to load class files automatically. We'll do this by calling the SPL autoload register function, passing in a callback function that will be called whenever a previously unused class is referenced, passing in the name of that class as an argument. In the body of the function, we'll require that class in the source folder using the dir constant to reference the directory of the current file. The class variable passed into the function contains the name of the class you're trying to use. So as the file name matches the class name, we can just add the .php suffix and we'll get the right file name. In a larger project, you'd probably use Composer's autoloader, but again, for the purposes of this video, we're keeping it as simple as we can. Then, at the end of the script, now we can use the controller class we just added. So instead of printing out the ID variable, we'll create a new object of the product controller class. Then we can call the processRequest method on this, passing in the request method, which we can get from the server superglobal, then the ID. So now if we make a request to /products, the controller class is loaded automatically, and we get the request method printed out, which is get, and the ID is null. If I add the ID, then we get that printed out too. If I change the request method, for example to post, then this is what is printed out. Back in the controller, now we can actually process the request instead of printing out this message. We're going to base the response on the request method and the ID. If there's an ID, then it's a request that affects a single resource, and if not, it's a request that affects a collection of resources. Instead of doing all the processing in one method, let's add separate methods for each one of these. A process resource request method, passing in the request method and the ID as arguments, and a process collection request method, to which we'll just pass the request method. Then, back in the process request method, we can call these two methods. Let's start by processing the collection requests. A GET request to /products should return a list of products, and a POST request will create a new product. So in the process collection request method, let's check the request method with a switch statement. If it's GET, we'll return a list of products. The standard format of an API response is JavaScript object notation, or JSON. So let's start by just outputting an array containing a sample element encoded as JSON, then a break statement to end the case block. If we make a GET request to /products, then we see the array in the response body. However, if we look at the content type response header, it's set to text/HTML, which is the default. As we're returning JSON, we need to set this to the JSON Content-type. Instead of doing this in here, as every response we send back from the API will be in JSON format, we'll do it in the index script. So just after we set up the autoloader, we'll call the header function, passing in a string to set the content type header to application/JSON, and also additionally specifying the character set as UTF-8. So when we make the same request, the content type header is set to JSON. Plus, using HTTPie, the response body now contains additional color formatting. Now we have this set up, we can return some actual data instead of this hard-coded value. I'm going to create a database quickly by running this SQL. This will create a database called productDB and a table in that database called product. This table contains various columns of different types to demonstrate how these are handled in an API client and how they're JSON encoded. There's a link to the source code that includes this SQL in the description of this video. Let's run that. And there's the database and the product table. While we're here, let's just insert a couple of example records into this table. We don't need to provide values for the ID column, as being an auto-increment column, values for this will be assigned automatically. If we browse the table, there are the two records. Now we can connect to the database from PHP. First, let's add a class to represent the database connection. So we'll add a new file in the source folder called database.php. In here, we'll add the PHP opening tag and the class definition. To connect to the database, we need details such as the host name, database name, username and password. Let's pass these values in when we create an object of this class using the constructor method. We'll add arguments for the database host, database name, username and password. If you need any other values, like the port for example, then you can include them here. We'll use constructor property promotion to automatically create private properties for each of these and assign the values of these arguments to these properties. Next, let's add a method called getConnection, which will return a PDO object. In the body of this method, let's create a variable for the DSN containing the host name and database name using the values of the properties we created above. Then we'll create a new PDO object passing in the DSN, username and password, and we'll return this object from the method. In the index page, let's create an object of this class, passing in the database host, name, username and password. I'm using the root account, which by default has a blank password. This is fine when you're developing locally, but on a production machine the connection should have its own username and password. Also, to keep it simple, I'm going to hard-code these values in here. But in reality, what you'd probably do is have these settings in a separate config file. To test the database code we just created, let's call the getConnection method on this object. If we make a GET request to /products, then we get the same response as earlier with the JSON test data. This means that the class has been loaded automatically and we connected to the database successfully. However, let's see what happens if I get one of the database connection details wrong, for example, an incorrect password. Now if we repeat the request, we get an exception. This is as expected. However, by default, the exception details are formatted as HTML. We always want to return JSON from the API, even if there is an error. To fix this, we could put a try-catch block around the getConnection method call, and output the error details as JSON in the catch block. Instead, however, let's add a generic exception handler that will output any unhandled exception as JSON. We can do this with the setExceptionHandler function. This takes a callback function that will be executed when an unhandled exception occurs. The single argument to this function is an object of the throwable class. So let's add a new file in the source folder called errorhandler.php. And in here, we'll add the PHP opening tag and the class definition. Then let's add a method called handleException with the single argument of type throwable that represents the exception that's been thrown and doesn't return anything. In the body of the method, we'll output some JSON that contains various data from the exception object. We can get the error code, the error message, the file it occurred in, and the line number in that file. In addition to outputting the exception details in the response body, let's also set the HTTP status code to 500, indicating that there is an error on the server. To use this class as the generic exception handler, in the index file, we call the setExceptionHandler function, passing in a string that identifies the handleException method in the errorhandler class we just added. We do this as early as possible in this script so that it's enabled as soon as possible, but so that the class is loaded automatically, we have to do it after we've created the autoloader. Let's make the API request again, and now we get the error details encoded as JSON along with the 500 internal server error HTTP status. Now we've tested the error handler, we can change the password back to the correct one. Next, we can use this database connection to make a query to the database. We'll do this in a separate class. We'll start by adding a new file in the source folder called productgateway.php. This class uses the table gateway pattern. Basically, its methods serve as a gateway to the product table in the database. We'll add the PHP opening tag and the class definition. The methods in this class depend on a database connection, so we'll pass an object of the database class in using the constructor. All the methods in this class are going to use the database connection. So instead of using constructor property promotion to simply store this value in a property, let's add a private property to the class to store the PDO connection object. Then in the body of the constructor method, we'll call the getConnection method on the database object and store this in the property. Then let's add a method to get all the records from the product table. We'll add a new public method called getAll, and this will return an array. In the body of this method, we'll add a variable containing the SQL to select all the records from the product table. We'll keep it simple with no order by clause or limit or anything like that, just the SQL to select all of the records. Then we'll call the query method on the connection object, passing in the SQL and assigning the returned PDO statement object to a variable. We want to return an array of rows. So let's initialize a variable with an empty array, then we'll use a while loop to fetch each row in turn as an associative array. Inside the loop, we'll append the row to the array, and finally in this method, return the array of row data. Now we can call this method to query the database, which we'll do here in the product controller class. However, instead of creating an object of the product gateway class in here, we'll pass one in as a dependency. So let's add the constructor method with a product gateway object argument, and we'll add a private visibility modifier to this so that the value of this argument will be assigned to a private property with the same name. Then, in the process collection request method, instead of outputting this hard-coded array, we'll call the getAll method on the gateway property. To get this working, back in the index script, we just need to stitch all this together. So instead of calling the getConnection method in here, we'll create a new product gateway object, passing in the database as an argument. Then we can pass this gateway object in as an argument when we create the product controller object. Let's give that a try. Now if we make the same request again, we get the JSON containing the two records from the database that we inserted earlier. Note, however, that the values for each record are encoded as strings, even though in the database the ID and size columns are integers and the isAvailable column is Boolean. This is because PDO is converting these values to strings. If the PDO stringify fetches attribute is true, then all values will be converted to strings, so we need to set this to false. We also need to set the emulate prepares attribute to false so that this works. So in the database class, when we create a new PDO object, we'll add a fourth argument that's an array, and we'll set both the emulate prepares and stringify fetches attributes to false. Now if we make the API request again, the numbers have no longer been converted to strings. Note, however, that the Boolean value is also a number, 1 or 0. This is to be expected as internally the database server stores Boolean values as 1 for true and 0 for false. If you want these to be Boolean literals in the JSON, then they have to be converted manually. So in the product gateway class, inside the while loop where we're getting each row from the database, before we append the row to the array, we'll cast the isAvailable column to Boolean. Now, when we make the API request, the isAvailable column is output as a Boolean literal, true or false. So when we make a GET request to the collection URL /products, we get a list of all the products. Next, let's add the functionality to create a new product, which we do by making a POST request to the same URL. So in the product controller class, in the process collection request method, we'll add a new case to the switch statement for when the request method is POST. First, we need to get the data from the request. With a POST request for a regular web form that you would submit from a browser, the data from that form would be available in the POST array. So let's assign that array to a variable and print it out to see what we get. If we make a POST request to the collection endpoint with some data in the request, we get an empty array printed out. By default, HTTPie sends data in the request encoded as JSON. As the API is responding with JSON encoded data, we'll require that data sent to the API is encoded as JSON also. Instead of the POST array, we get JSON data from the request directly from the PHP input stream. We do this by using the fileGetContents function, passing in this string to identify that stream. Now if we make the same request, we get a string containing some JSON. Let's decode that JSON using the JSON decode function, passing in true as the second argument to get an associative array. If we make the request again, now we have an associative array containing the data from the request. If we add another item of data, this adds a new element to that array. Note that with HTTPie, by default, values are encoded as strings. To send a literal integer or Boolean value, for example, we need to add a colon before the equals sign. Now the value for that field is encoded as an integer. Note what happens though if we make a POST request but don't include any data in the request. We get null. To make the API more robust and handle this possibility, we need to check that this value isn't null. The JSON decode function will return null if the JSON is invalid or if there isn't any data. We could check for this with an if statement, but a simpler way to do it is to just cast this value to an array. If the value is already an array, then nothing happens. If it's null, then it will be converted to an empty array. If we make an empty POST request again, now we get an empty array instead of null. Now we have an array of data from the request, we can insert a new record into the database. To do this, first in the product gateway class, let's add a new public method called create, with an array argument for the data. Inside this method, we'll add a string containing the SQL to insert a new record into the product table, specifying the name, size and isAvailable columns with placeholders for the values. Then we'll use a prepared statement for this, so we'll call the prepare method on the connection property, passing in the SQL. Then we can bind the values to the placeholders. First, the name, which is a string. Then the size, which will default to 0 if it wasn't supplied, binding its value as an integer. Finally, the isAvailable column, which will default to false, and we'll cast this to Boolean just in case the value was supplied as another type, and we'll bind this as a Boolean value. Then we'll execute the statement, and we'll return the ID of the record that was inserted, which we can get by calling the lastInsertID method. This method returns a string, so we'll add the string return type declaration to the function definition. Then, back in the controller, instead of outputting the data from the request, we can call the create method on the gateway property, passing in the array of data. This returns the ID of the newly created record, so we'll assign that to a variable. For the response to this request, we'll output some JSON with a message saying that the product was created and its ID. Finally, we'll add a break statement to end the case block. Let's give that a try. If we make a post request to the products endpoint, passing in just the product name, we get a reply saying the product with an ID of 3 was created. If we include the size, we get a product with an ID of 4, and if we include the isAvailable field, we get product ID 5. In the database, we can see the 3 new records that we just inserted using the API. Where we didn't specify values for the size and isAvailable columns, the values for these were defaulted. Note that in the output when we make this request, we have a status code of 200. This is the default status code if we don't change it. However, when inserting a new record, the status code to use is 201. So let's set that using the HTTP response code function. Now if we make a successful request to create a new product, we get the 201 created status code. Watch what happens though if we make a request with no data at all. We get a couple of errors. The first tells us we have an undefined array element. The second is a database error that comes from trying to insert a record with no value for the name column. However, note that the first error isn't encoded as JSON, even though we configured a generic exception handler. What's actually happening here is that a PHP error has occurred, which isn't caught by the custom exception handler. To catch the error, we have to set a custom error handler using the setErrorHandler function. The callback function we pass to this has this signature, with the error number, message, and so on. So first, in the errorHandler class, let's add a new public method called handleError, which fits this signature, although we only need the first 4 arguments. Inside the method, instead of repeating what we have in the exception handler, we can just throw a new exception of the errorException class. This exception class was designed to represent errors as exceptions. The constructor takes various different arguments for the various attributes of the exception. So in the body of the handleError method, we'll throw a new error exception, passing in the error message, 0 for the exception code as we don't have this, the error level, file where it occurred, and the line number in that file. Then, in the index script, before we set the exception handler, we'll call the setErrorHandler function, passing in the callback function we just added. Now if we make a post request without any data, we get the error encoded as JSON. We also no longer get the other exception, as execution halted after this exception occurred, which is as expected. Now we can look at the reason why this error is occurring. We're getting an undefined array key error on line 38 of the product gateway class. On that line, we're trying to use an array element that doesn't exist. This is because we didn't send any data with the request. So before we try and save the data to the database, we need to validate it. We'll do this in the product controller class. Let's add a new private method called getValidationErrors. This will have one argument, which is the array of data to validate, and will return an array of error messages. In the body of the method, first we'll initialize an empty array. Then we'll validate the name field. We'll keep this simple and just check to see if it's empty or not. If it is, we'll append an error message to the errors array. Next, we'll validate the size. This is optional, so first we'll check if a value has been supplied. If so, we'll use the filter var function with the integer validation filter to check that it's an integer. If it's not, this function will return false, so we'll explicitly check for that. The reason we check it's specifically Boolean false, and not just negate the result of the function call, is that it could be 0, which is still a valid value, but this evaluates to Boolean false. If it's not valid, we'll append a suitable message to the errors array. Finally, at the end of the method, we'll return the array. Then, back in the processCollectionRequest method, before we call the create method, we'll call the method we just added, passing in the data from the request, and assigning the return value to a variable. If this variable isn't empty, then we'll output the errors as JSON in the response body, and break out of this case block. We'll also return an HTTP status code of 422, which is unprocessable entity. Let's give that a try. Now if we make a request with no data, we get the error in the body of the response and a 422 status code. If we add an invalid size to the data, then we get the error message for that too. If we send valid data, then the record is created and we get the 201 status code. So now we can make a GET request to this collection endpoint to get a list of all products, and a POST request to create a new one. There are other HTTP request methods we can use, for example delete. If we make a delete request to this endpoint, we get an empty response body with a 200 status code. We should respond differently if this method isn't allowed for this endpoint. So let's add a default block to the switch statement, and in here we'll respond with a 405 status code, which is method not allowed. When responding with this status code, the standard requires you to include the methods that are allowed in an allow header. So we'll add the call to the header function with an allow header specifying that get and post are the only methods allowed on this endpoint. Now if we try an invalid method, we get the method not allowed response, and the allow header is included. If we try a valid method, such as get, we get a successful response as expected. That completes the processing for the collection request. Next, let's process requests where the product ID is included in the endpoint. The first thing we need to do for these requests is to check that a record already exists in the database for the given ID. In the product gateway class, let's add a new public method called get with a string argument for the ID. As above, we'll use a prepared statement for this. So first we'll write the SQL to select the record from the product table using a placeholder for the ID. Then we'll prepare the statement, passing in the SQL, and bind the value of the ID argument as an integer. Next we'll execute it and fetch the record as an associative array. Finally, in this method, we'll return the data. The fetch method will return an array if the record was found or false otherwise, so we'll add the appropriate return type declaration to the function definition. Then, in the controller, in the process resource request method, we can call the get method on the gateway property, passing in the ID. Then, for now, let's just output the return value encoded as JSON. Let's give that a try. If we make a GET request to the /products/1 endpoint, then we get the product record in the response body in JSON format. Note, however, that the isAvailable column is an integer instead of a Boolean value. In the getAll method in the product gateway class, we manually converted this column to a Boolean value when we retrieved the data. Let's do the same in the get method. So, once we've fetched the data, if it isn't false, we'll cast its value to Boolean. Now, if we make the same request again, the isAvailable column is Boolean. This request worked because a record with an ID of 1 exists in the database. If we make a request with an ID that doesn't exist, we just get false. Back in the product controller class, let's check for this, and if the product wasn't found, we'll respond with a 404 status code, a suitable message in the response body, and we'll exit from the method with a return statement. Now, if we make the same request, we get the 404 not found response. Next, we can process the request based on the HTTP request method used. As before, we'll do this with a switch statement on the method argument. If the method is get, we'll do what we're already doing, which is to output the product data as JSON, then we'll break from the case block. We don't need to specify the status code as 200, as this is the default, but you can if you want to. So if we make a GET request to the endpoint for a product that exists, we get a 200 response with the product data in the response body. Next, we'll process a request to update an existing record. We'll do this with a patch request. So let's add a patch case to the switch statement. In here, most of this will be similar to what we're doing down here when we insert a new record. So let's copy this whole case block and paste it in the patch block. The first part will be the same, where we get the data from the request and validate it. However, instead of calling the create method on the gateway object, we need a different method to update an existing record. So let's add a new public method to the product gateway class called update. We'll pass in the current product details and the new details from the request data, and we'll return an integer, which will be the number of rows in the database that were updated. In here, we'll add the SQL to update a record, identifying the record with a where clause for the ID. We'll prepare the statement as before, passing in the SQL. Then we can bind values to the placeholders, starting with the name. If a new value has been passed in the request, we'll use that. Otherwise, we'll just use the existing value. If the value hasn't changed, the database will detect this and not update anything. We'll do the same for the size and isAvailable columns. Then we'll bind the ID value, which we get from the current product values, and we'll execute the statement. We'll call the row count method to set the return value from this method. Then, back in the controller, instead of calling the create method, we call the update method we just added, passing in the current product as the first argument. This returns the number of rows affected, so we'll change the name of the variable we assign this to accordingly. For the response, we'll use the 200 status code, so we can remove this call to the HTTP response code function, as this is the default. For the body of the response, we'll include the ID in the message, and return the number of rows that were affected. Let's give that a try. We'll send a patch request to the product with an ID of 1, updating the name. We get a successful response telling us 1 row was affected. If we make a GET request to the same endpoint, then we see the name value has indeed been updated. If we make the same patch request again, then no rows were affected as no values were changed. We can update all of the columns, and the validation works as before. However, if we just want to update the size, for example, then we get a validation error saying that the name is required. The name is only required when we're creating a new record, so we need to do some conditional validation on this. In the getValidationErrors method, we'll only add this validation message for the name field if we're creating a new record. So let's add a new Boolean argument to the method to identify if it's a new record or not, which we'll default to true. Then, before we check if the name value is empty, we'll check if this variable is true. Then, where we're processing the patch request, we can pass in false as the second argument when we call the getValidationErrors method. Let's give that a try. If we make the same patch request as before, just passing in a value for the size, now we get a response saying the record has been updated, and if we view that record, we can indeed see that the value has been changed. The final operation we want to carry out on a resource is to delete it. So let's start in the processResourceRequest method by adding a delete case to the switch statement. Then, in the productGateway class, we'll add a new public method called delete, passing in the ID as a string and returning an integer. In the body of the method, we'll add the SQL to delete a record from the product table identified by the ID. We'll prepare the statement, bind the ID value to the placeholder, and execute it. Finally, we'll return the number of rows affected. Back in the controller, we'll call this method on the gateway property, passing in the ID and assigning the return value to a variable. For the body of the response, we'll output a message, the number of rows that were affected, and we'll end the case block with a break statement. Let's give that a try. If we send a delete request to the product with an ID of 1, then we get a result saying the product was deleted, and 1 row was affected. If we then try to read that resource by sending a GET request to the same endpoint, then we get a 404 response saying the product wasn't found, confirming that the record was deleted. One final thing we need to do in here is respond to any request that doesn't use one of the above methods, as we did below. So let's add a default block, set the HTTP status code to 405, and send an allow header with the allowed methods of get, patch, and delete. So now if we send a post request, for example, to the endpoint for the product with an ID of 2, we get the 405 method not allowed response, including the allow header. So now you know how to create a RESTful API using plain, object-oriented PHP and MySQL. We can make requests to list all resources, to create one, to show an individual resource, update it, and delete it. There's a link to all the code shown in this video in the description, along with links to sites shown and relevant documentation. Please don't forget to like, comment, and subscribe, and as always, thank you for watching.